everybody. And yes, it is really me at this time. Kia ora, I'm Gemma and I'm from Dunedin, and I'm a virologist of sorts, but I use genomics and our genomics toolbox to answer questions in virology. And so imagine it was December 2019, it's New Year's Eve. Do you remember what you were doing or where you were? I was a new parent in 2019, and so I was probably struggling to stay awake at 10 o'clock at night. But probably unbeknownst to you, that there was a new pandemic just bubbling away, awaiting to happen. So this is a cluster of cases in intensive care in Wuhan Central Hospital. They had this undiagnosed pneumonia, and all our diagnostic techniques, our tests, were negative, okay? And so, luckily for the world, there was scientists that were embedded in the public health system in China that were able to use genomics techniques to rapidly diagnose this new coronavirus. And within just days of these cases being admitted to ICU in hospital, there was this new coronavirus, which we'd never seen before. A whole genome was released on Twitter, back when Twitter was cool. And this release, this public sharing of genomic data, allowed diagnostic tests to be developed, vaccines and other preventative therapeutics to be designed as well. Now, this sort of framework where you go from sick person to rapid diagnostics to tests and therapeutics does not exist in New Zealand, and we're really, really, really far away from embedding this framework in the New Zealand health system. It does exist around the world, and of course we're very lucky in some senses that this pandemic emerged in China, because this allowed the world to learn really rapidly what this pandemic was and how we can prevent it through vaccination. But what we are good at, I'll tell you the good news before I tell you all the bad news, is using genomics. And I think during the COVID pandemic, we learned that genomics played this starring role in disease prevention and information. And it allowed us to use genomic data to inform decisions about public health. So for example, we used genomics to prove that the virus was airborne, how it was spreading through MIQ and on planes. And this therefore informed masking policies and other policies like testing. We were able to track small chains of transmission through the community to inform whether or not we had to lock down the country or lock down a region. We used early warning detection systems such as wastewater detection, and we were able to then, when we opened the borders, to understand how new variants were coming into the country and how they were spreading, and estimate their spread through time and space. So genomics is really informative, and I think it became part of everybody's language during the COVID pandemic. But we have quite short memories, and so does funding. And at any one time, there are dozens of viral and other pathogenic threats waiting to cause the next pandemic. At the moment, there is this bird flu. Now, this new lineage of avian influenza virus, H5N1, emerged at the same time as COVID did. But the world was quite busy dealing with one pandemic, and this kind of got ignored. And while we were ignoring it, it spread to every continent apart from Oceania. And so New Zealand had a dress rehearsal for this. So in December in Otago, an Otago egg farm detected another strain of avian influenza virus. This was a locally adapted strain. It wasn't the one that's spreading around the world. And it wasn't because we were prepared or very good at containment. We got really, really lucky. And I think anyone working in that response would tell you so. Okay, so we got really lucky. However, this situation is getting really terrible around the world. It is spread to lots of mammals, and it's spreading to humans. And so we need to do something now before this arrives in New Zealand, and we're not doing anything. As I said, it's going to get worse, don't worry. So this virus has spread to lots of mammalian species. most part, in the first couple of years of the emergence of this lineage, it spilled over, meaning that this virus wasn't transmitting between these mammalian species. Because it is a bird virus, it's actually really hard for that virus to spread between mammals, because we have a really different way of transmitting viruses. However, since it's been 5 years now of this evolution of this lineage, it's spread not only to domestic animals through poultry, but it's spread to domestic mammals like cattle, and importantly, it is now spreading among domestic mammals like cattle, and it is spread to every single US state across America, and it is spreading among cattle. It is only spilled over to cattle a couple of times. So that shows that it's spreading. And using genomics, we can tell that this lineage is now spreading among cows. It is now spread to pigs, just last week, in fact, the first detection in pigs. And pigs are a really important mixing vessel for new strains of pandemic flu to emerge in humans. There has been countless human cases, and more often now, there are human cases that have been reported that have no direct contact with infected animals, which means that it's possible that the virus has acquired the ability to spread among humans, or at least that's very close to doing so. So New Zealand remains free of this virus, and so does the rest of the continent. However, if or when this virus emerges here, it is likely to be catastrophic and cause ecological collapse. And that's because most of our endemic species are birds. And so at the moment, this is an animal virus, and it's a very well-adapted bird virus. Most of our birds are really endangered. They're a taonga species and already grappling with lots of infectious diseases of their own. And so this could definitely cause catastrophic extinction. It is also spreading among livestock, and our export industries would likely hugely suffer if this virus were to occur here. And sadly, New Zealand is probably as prepared or even worse than it was in 2019 for pandemic preparedness. And that's because we're really quick to forget the capability and capacity that we built up very rapidly during the pandemic. And underfunding and lack of interest in this subject has really made this a huge concern among researchers. And so this lineage, H5N1, that is spreading around the world is likely to enter New Zealand. At the moment, because it remains an animal disease, it's probably likely to come here through migratory bird species. It could, of course, come through an infected human as well. So if it comes through birds, then what are we doing about that? Well, we like to think that New Zealand, Aotearoa, is this sort of geographically isolated place, and we're probably protected. And that was probably the case before this new lineage emerged, which has a huge expansion in its host range. And so you can see from this image that migratory birds that come to New Zealand are globally connected. They fly all over the world and up to the northern hemisphere where this virus is highly prevalent. As well, this virus is on the mainland of Antarctica, and of course New Zealand's territories and its sub-Antarctic islands provide nice stepping stones for this virus to incur into New Zealand. And so there are many different routes that this virus could take. So my group is trying to understand the risk at which this virus might enter New Zealand through these migratory birds. And so we're doing lots of sampling, which sometimes involves sending my postdocs down cliff faces to catch birds. And we're doing lots of sea and shorebird sampling, as well as sampling the environment to better understand the prevalence of avian influenza viruses generally. So these are mainly low pathogenic avian influenza viruses that these birds have lots of, to better understand how they interact with influenza viruses around the world and see if we're sort of a global sink, or in fact we're globally connected to lots of influenza viruses around the world. And in fact we see that New Zealand's birds carry influenza viruses that are genetically connected to all of these species around the world. And we're this really important place in ecology for these birds, where the basically endpoint, this terminus for this important East Australasian flyway site. And so thousands of birds come to New Zealand every spring and risk bringing this virus into New Zealand. So we're using genomics to not only just survey to see what's there and understand the global connectivity of these viruses, but perhaps we can also use genomics to enable us to better predict at what time and what routes this virus might enter New Zealand. And so this isn't just a bird problem, it's not just an environmental problem, it's not just a human health problem, but it's bringing all those things together. And we really need to stop looking at this as a really siloed approach. Understanding human health doesn't, in pandemic preparedness anyway, is not separated from wildlife health and other animal health as well. And that's it. Thank you very much.